So now let us continue. Here in the question D, we want to compute f(y(x) here. It means we take the partial derivative with respect to x of df over dy. In the part B, we know that fy, partial derivative with respect to y, is this term. Plug it in here, we have that this partial derivative with respect to x of this. Therefore, we treat y and these, the other things, as constant. Only things here matters is x cubed and e to the x squared plus y cubed here. So constant, we can take it out of the partial derivative. Therefore, it will be 5 square root of 2 over 2 square root of y d over dx here, x cubed plus 3y squared d over dx of e to the x squared plus y cubed here, which is 5 square root of 2 over 2, and here it will be 3x squared, right? Here, again, we use general 3y squared d over dx of x squared plus y cubed here, e to the x squared plus y cubed. Okay? Then this guy, we can simplify it. It is 5 square root of 2 over 2. Yeah, 5 times 3 will be 15. Okay? X squared over square root of y. Here, 3y squared, partial derivative with respect to x squared, here give us 2x. Then 2 times 3 will be 6 here. Okay. And e to the x squared plus y cubed. That's it for the part D. Look at this. This is fxy, which is this guy. Okay. And here, fyx. What do you think about these two? Yes. Wait. While copying this, the number 2 just disappeared. Let me recopy it. Yeah, they are the same. Okay. It makes sense because from this theorem, we know that if f is defined on a disk that contains a point here, AB, and the function fxy and fyx are both continuous on D, then these are the same. They're equal to each other. Okay. Let us continue. That is part B, D already, right? We're trying to compute E and F. E, we want to compute fxx here, which is d over dx of fx. And fx, we found it in the question A or B's. which is 15 x squared square root of 2y plus 2x here, e to the x squared plus y cubed. Okay. Again, we take partial derivative with respect to x here. So we treat others as constant. The first guy becomes 15 square root of 2y partial derivative with respect to x of x squared here. Okay, and this guy here, this is a product, so be careful. It is a product, partial derivative of a product. The number 2, we can write it here. It is 2x times e to the x squared plus y cubed. Right? Product of two things, x and e to the something is here. Okay. If you don't remember, let me remind you about this formula. F dot g prime, it will be f prime g plus f g prime. Okay. Therefore, we have this partial derivative of x squared gives us 2x, right? Therefore, 2 times 15, it would be 30. Square root of 2y here, x. And here, number 2 is a common factor. Okay. Partial derivative of x times e to the x squared plus y cubed plus x times partial derivative with respect to e to the x squared plus y cubed. Do it very slowly, otherwise you may got some mistake here. Okay, product rule. Therefore, we can simplify it. 30, let us write it as x and square root of 2y. Here, the number 2 is outside, and partial derivative with respect to x of x is 1. It will be e to the correct. Here, it will be x. E partial derivative of this, we use the chain rule, d over dx of x squared plus y cubed e to the x squared plus y cubed here. Okay, continue. 30 x square root of 2y plus 2, and here will be, so see, this is the like term of the two things. We can factor it out, right? If we factor this out, the first guy will be 1 here, plus x times here will be, yes, 2x, times here. And what else? E to the x squared plus y cubed. Okay, that's it. Or it will be 30x square root of 2y. You can distribute it here, or you just can leave it this way. Okay, that is the question E. Let us continue. F, we need to compute fyy, which is partial derivative with respect to y of fy, or this guy. And we know that partial derivative with respect to y is 5 square root of 2 over 2 x cubed square root of y plus 3y squared e to the x squared plus y cubed. Okay, same story. This is the variable. Okay, again, the second terms we should use the product rule. Okay, and the first guy becomes partial derivative with respect to, let us write the constant out first, make our life easier. Okay, partial derivative with respect to y of 1 over square root of y. 1 over square root of y, or we can write it y to the 1/2, right? And then y to the 1/2 in the denominator. We can bring it up to the numerator. If we do so, we need to change the power here from 1/2 to negative 1/2. Very good. That is why we have this. Okay. And here, the same story. Plus 3 partial derivative with respect to y of y squared e to the x squared plus y cubed here. From this, partial derivative of this will be, we take the power down here, which would be careful. This is a dot and product here. So we need to write a parenthesis, otherwise you may confuse the reader here. Right, be careful. Negative 1/2 and y to the negative 1/2 minus 1. Okay. 3 derivative of the first one, which is, or let us write it slowly, d over dy y squared e to the x squared plus y cubed. Okay, let us bring it down. It's easier. We have more rooms here. Okay, and then what is next? Yes, the second term here, it would be y squared d over dy e to the x squared plus y cubed here. Okay, then what do we have? Let us simplify it. Here, negative 1/2 minus 1, it will be negative 3/2, right? Therefore, let us write this constant out first. X cubed, and negative here, it will be negative, and 2 times 2, it will become 4. Sorry, let us continue. And here, y to the negative 3/2. Again, it is a negative power, so we can bring it down to the denominator, which will be y to the 3/2 here, okay? And y to the 3/2 here, or we can write it as square root of y cubed. Very good. This guy, the number 3 is outside. Again, here derivative of this will be 2y e to the x squared plus y cubed. Okay, this guy will be y squared, and partial derivative of this guy With respect to y, again, we use the chain rule. We take a partial derivative with respect to y of the power here, which will give us 3y squared, partial derivative, and times e to the x squared plus y cubed. Again, this is the like term, so we can factor it out, right? Simplify it. Here it will be negative 5 square root of 2 over 4. We can write it as x cubed over square root of y cubed. And here it will be, yes, we factored it out, then it will be 2y plus 3y to the fourth e to the x squared plus y cubed. Okay, that's it.